Hello everyone, my name is Kunsong Zhao from Wuhan University, and today I'd like to talk about our work predicting crash fault residence via simplified deep forest based on a reduced feature set. My presentation consists of the following 5 parts. First, I will give a background and motivations of our work. As scale of and complexity of the software keep increasing and some unexpected factors during the development and maintenance process, and the bug hidden in the program can cause software crash. Once the crash is triggered, the system will automatically generate a crash report to record the corresponding status at that time. So fixing crash fault is a critical task for software quality assurance. Previous work proposed an automatic method called Creator to predict whether the crash fault residence is inside the stack trace or not. However, this work neglected the selection process for representative features and only used the traditional classifiers for their purpose, which may not achieve satisfactory performance. For this purpose, we want to develop a method to address these limitations. Here I will give a brief introduction of 2 key techniques used in our work. First, the feature subset selection method CON that introduces a consistency measure as the criterion to evaluate a selected feature set. CON calculates the consistency between a feature subset and class labels. It reserves the smallest set of features that has the same consistency as whole feature set. Second, the deep forest decision tree ensemble method, which uses a cascade structure with ensemble forest for feature representation learning and classification. After introducing the 2 techniques, here I will illustrate our CONDF framework. This figure demonstrates an overview of our proposed CONDF method, which consists of a feature reduction stage and a classification model construction stage. In the first step, we selected the important features from the original crash data as candidate feature subset, and then in the second step, we apply the simplified deep forest techniques to the reduced feature set for building the prediction model. In this work, we specify that each level of the cascade consists of the 4 completely random forests and 4 random forests, and each forest consists of 500 trees. Next, we'll describe our experimental evaluations. In this work, we employ a public available benchmark dataset that includes 7 Java projects and with 3 performance indicators to evaluate our method. We empirically design 3 research questions to evaluate our method from different aspects. The first research question is the prediction performance of our proposed CODF method better than that of ensemble-based method? And we compared our method with the following 6 methods, include a state-of-the-art method. These tables and figures report the experimental result and the statistical result. We can find that our proposed CONDF method performs significantly better than the comparative method. The second research question is how effective our CONDF method is compared with other classifiers with feature selection method CON. We designed the following 5 comparative methods. And the result demonstrated that the feature set selected by CON is more appropriate for deep forest classifier to obtain better performance for this task. And the last question is, are the selected features by CON more effective to performance improvement than that by other feature selection methods? And we compared our method with the following 6 methods. And the results show that the feature set selected by the C1 method is more effective for the deep forest classifier to achieve better crash fault radix prediction performance compared with the features selected by other classic feature selection methods. Last, I conclude our work. In this work, we propose a novel composite method called C1GF. C1 reserves the important and representative features, and GF builds more effective classification models. And the experiments showed the inferiority of our C1GF framework. In the future, we plan to apply our C1GF method to projects developed in other programming languages and with real-world crashes. In addition, we plan to consider the class-imbalanced issue of crash data in the process of model building. And thanks for listening.
All right, so we have the Q&A for predicting crash fault residence via simplified deep forest based on a reduced feature set. We have Kunsong here, the author. So any questions? Yeah, feel free to put it in the chat. Okay, I might kick off with a simple question. So I have seen that your evaluation has been done on Java. So you think it would be applicable to other languages as well?
Yes, thank you for your question. And we plan to apply our method to the project developed in other languages, and we treat it as a future work. And I think our methods can apply for other projects developed in other languages.
Okay, thanks. Okay. So next question would be, I have seen that in a few situations, the ConDF technique that you propose still cannot outperform the ConBack or ConBRF. Can you explain those kind of exceptions?
I think the main reason is the ConBRF use a balanced random forest, which is non-sensitive to the data distribution. So it will be it will get more get better performance on the projects like Code C and Zhou. So I think it's due to the data distribution.
I see. And so do you think this technique can be applied to other research areas as well?
Yeah, I think I think it can apply for other research area, because we proposed a composite method. I think it's just.
Whoops. Oh, I think we lost the author. So next session would be the social session. So see you there. Bye.